actually 2 more ratios that we have. So we defined our ratios on Friday. Okay, and by definition, we said that we're going to call this one sine, and sine is equal to opposite over hypotenuse, and cosine is equal to adjacent over hypotenuse. And that's where we introduce this strange little word, SOHCAHTOA, to remember which ones go with which ratio. Okay, and then we just kind of got started on labeling our triangles, and then practicing writing out all 3 of our ratios. Okay, so we're going to continue with that. I want you guys to get really comfortable with identifying, like labeling the sides of your triangles, and then deciding. Okay, so now today we're going to transition a little bit more into looking at a triangle and deciding which ratio should I use in order to solve for my unknown angles. Okay. Now before we do that, we just need a little bit of calculator practice to make sure that we can actually solve what the angle is. So go ahead and pull out your calculator. Okay? And if you need to, double check to make sure you're in degree mode. Okay? So if you hit the mode button, okay, your degree word should be lit up in a dark box. Okay, we did that already, but just a reminder, whenever you reset your calculator, so whenever we have a math test, I don't know if they have you reset it in science class if you're doing a unit on physics or something like that, but just a reminder, if you have to reset it and you're doing trigonometry, you do degree mode in grade 10. Okay? So if you don't reset it, you don't have to double check that. Okay, but that's one of the first things I'm going to ask when sometimes I see people's work and they're getting decimals when they should be getting numbers like 36 or something. It's probably just because they're in radian mode. Okay, so remember, when we have to solve for this unknown angle, okay, what we're trying to do is we're trying to get sine, okay, we're trying to get the angle by itself, so sine kind of like needs to go to the other side of the equation. And the way that we do that is we use the inverse sine function. Okay guys, we only ever use this when we're trying to find the angle measurement. Okay, it's just to find the angles. So we just do sine of 0.25. So go ahead and put that in your calculator. And tell me what the measure of the angle is to the nearest tenth. We're going to be rounding to the nearest tenth. So you should have gone second function sine of 0.25, your bracket, equals. Okay. So remember, when we're rounding, okay, we want to the nearest tenth, so we look at the 4, we check with the nosy neighbor next door, and it's a 7, so because it's 5 or more, we're going to round up. Okay, so 14.5. Don't forget that little degree sign. Okay, our angles always have a unit, and it's in degrees. Okay, so now make sure that you can do that for cos as well. So we're going to get x all by itself, and we're going to do the inverse cos of this one, and it's a decimal. 0.64. Inverse cos 0.64 and bracket. Okay, so 50.2. Just the boxes so you can see them a bit easier. Okay, nothing changes if they give us a fraction versus if they give us a decimal. Okay, we're going to do the exact same thing. We're going to isolate for x. So when sine goes to the other side, it has to be the inverse sine, okay, of 6 divided by 11. So inverse sine, 6 divided by 11, close your bracket. Okay, 33. Okay, so here we're looking at the tens. Okay, those neighbors 5 or more, so we're going to round up, so 33.1. All right, and final one, we're going to do the inverse cos, 7 over 9. Okay, 38.9. so I want to make sure that you're all, okay, using your calculator and making sure that you're, like, what you have on your calculator is the same as what I have on mine and that you're checking it out. Yeah. Alright. We have that all written out. We are ready for our next example. Okay. So here, what we're going to do is, we're going to determine the measures of G and H to the nearest degree. So number one, as soon as we see a right angle triangle, okay, I want you to label it. Okay? And this one we're going to have to label twice because they want two different angles. Okay, so let's do angle G first. Okay? So we can always label the hypotenuse. Notice my little microphone going on. Okay. So we're doing that. Okay. So we lost 6 minutes. That's okay. Okay. So we can always label the hypotenuse. Okay. So that should be the first one that we label, is the hypotenuse, right? Directly across from our right angle. Okay. Then we narrow in, and let's do G first. So if this is angle G, now I'm going to label the other parts of my triangle. So this is going to be my, right? This is going to be my opposite side here. And this is my adjacent. Okay guys, what trig ratio, so tell me sine, cos, or tan, should I use in order to figure out the angle of G? Okay, I have an adjacent and I have a hypotenuse. So what am I going to use? Someone say that now. Okay. Okay, we're going to use adjacent and hypotenuse. Okay, so if we remember SOHCAHTOA, okay, so look for the ones that we have. We have adjacent and hypotenuse, so this time we're going to use cos. Okay, so thank you for trying, right? That's what I want, guys. Like, I want you to be like, take a risk. Like, maybe it's this, maybe it is, maybe it's not. Okay, so in this case, we're going to say that cos angle G is equal to adjacent over hypotenuse. So that means that cos G is equal to, now we're going to substitute in, our adjacent is going to be 6, our hypotenuse is 14. Okay, we want to get G all by itself. So to get cos to the other side, we're going to do the inverse cos. That's how we do angles. 6 over 14. Okay, inverse cos 6 divided by 14. Okay, and this time it said, let me check again, to the nearest degree. Okay, so the nearest degree would be nearest whole number. So we checked, this one is 64.6, so we're looking at the 4. We checked the nose neighbor next door, 5 or greater, we round up, so we're going to round up to 65. Now for H in black. Okay guys, when we pick a different angle, we have to relabel the triangle. Because, okay, I'm going to leave my purples there because that's in accordance to G. But with H, that's why I changed colors. So for H, this is now my opposite. Okay, that's across from H. And the one that's touching it, this becomes my adjacent. Okay, so what might be better for you when you're answering these questions instead of, because you might kind of get confused, well, which one am I looking at? Okay, you can either use a different color, or once you have solved for your angle, you could also erase the labels on your triangle and just start fresh for part 2. Okay, don't get confused by your own labeling, okay, if you're not using different colors. So in this case, okay, for angle H, I now have an opposite and a hypotenuse. So what trig function could I use? Sine, yeah. This time I'm going to use opposite over hypotenuse. Exactly. So we're going to do sine of H is equal to opposite over hypotenuse. Substitute in your numbers. Opposite was 6 over 14. That's 26. There we go. H, 6 inverse sine, 6 over 14. Head over to my calculator. Inverse sine, 6 divided by 14. Okay, that gets me 25. Okay. Now we did it this way because the question asked, use trig ratios to find out the angles. Okay guys, if I had used a trig ratio to find out this angle, okay, what else could I have used to find out this one if I didn't have to use a trig ratio? Remember on Friday we talked about a special thing that I called a theorem. It was the triangle sum theorem. Okay? What happens, like what do all of my angles have to add up to? Yeah. 180. 180. So don't forget, now this one we answered correctly, okay? But don't forget that sometimes you can take the shortcut. You can also say 180 subtract 90 subtract 65, and that would give us the 25 degrees as well, okay? So you can always double check your answers. Like if you add them up, they should equal 180 degrees. Okay, our right angle is 90, 65 plus 25 should be 180. Okay? So always, like, double check your answers. Now, if you're doing some rounding and it's off by, like, a decimal point, I'm not concerned. Okay? Alright. But here again, using the trig ratios. We're just going to stick with that. We're not going to take the shortcut yet. Not yet, anyway. Don't worry, it's coming. Determine the measures of k and m to the nearest tenth of a degree. Okay, so this is exactly like it was before. I want you guys to try it. Okay, I'm just going to come around, see how it's going. Okay, see how the labeling is going. Okay, but right away, you can always do your hypotenuse. And then identify, okay, start with k and label that and tell me what angle it's at. So in labeling your triangle, okay, across the angle, the triangle from K, okay, is going to be our opposite side. Okay, the side touching K, that's our adjacent. Okay, so that's step number 1, is making sure that you've labeled it correctly. Okay, and then taking a look and saying, oh, I have an opposite and I have a hypotenuse. Which one of my trig ratios do I want? So you look at your SOHCAHTOA. And you're like, okay, opposite and hypotenuse, that means I want sine. Okay, so our sine K is equal to opposite over hypotenuse. And then it's fun. Okay, so our K is equal to 3 over 8. So K is equal to the inverse sine 3 over 8. Okay, so let's head over. Inverse sine 3 divided by 8. Okay, 22.0. Okay, so you might be asking, and like say you just put 22, okay? If this were a test or a quiz, you would lose marks because you didn't include the tenth part. So just make sure that you're always double checking what the question wants. It's usually going to ask for the nearest degree, so the nearest whole number, the nearest tenth, or the nearest hundredth, so 1 or 2 decimal places. Okay? And then, okay, once you're done with that, if you want to, like, go ahead and erase your triangle, okay, the labels on it, okay, so that, right, you could do this, just so that you're kind of fresh. And now we're going to do M. Okay, hypotenuse stays the same, it never changes, but your opposite is now my opposite, and the one that's touching my angle, this becomes the adjacent. Okay, so and then I say, what am I going to use when I want adjacent and hypotenuse? Okay, awesome, we want our cos. Cos of M is equal to adjacent over hypotenuse. Substitute in our numbers, 3 over 8. Okay, take the inverse cos in order to find the angle. Okay, and then M is equal to inverse cos. divided by 8. Okay, 60. Okay, so 67.97. So normally it was set to the nearest tenth, so we look at the 9, but the 7 beside says we need to round up. So the 9 would become a 10, so we put a 0 there, and then drop one over, so it would be 68.0 as well. Okay. All right. Yes. After this part. Okay. So this part, okay, guys, this next part is just a few definitions. Okay, and we just have to learn where to draw the angles. If you're going to make a mistake in labeling your diagram for trigonometry, this is the mistake you're going to make. Okay, so we're going to go over it, and then we're going to head to the boards, and we're going to practice drawing some scenarios, kind of like from your homework, where you have to draw things and make sure that the right line is labeled and all that kind of stuff. Okay, so we're going to do some practicing with that. But first we need our definition. Okay, we have two things. The first one is called an angle of elevation, and the second one is called an angle of depression. So what happens is, I'm walking along. Okay, I'm looking ahead of me. This invisible straight line that's in front of my eyes, this is called the horizon line. Okay, the horizon line is straight out of my eyes. Okay, if I happen to notice a bird in the air, I look up, there's the bird. That's an angle of elevation. So if you look up, that's an angle of elevation. Okay, if I get to, say I'm walking along and I get to the edge of a cliff, right, and maybe there's a beach down there, and maybe there's a boat in the water, and I look down, okay, me looking down, okay, is an angle of depression. But it's me looking down from, okay, this horizontal line. Okay, so from here to here is the angle of depression. Not from my feet to my eyes. Okay, so guys, notice that it's not here. Okay, the angle of depression is from a horizontal line looking down. It's not from your feet. Okay, this is the guy's feet. Okay, it's not from his feet to his eyes. Okay, so let's write a few things here, and then let's take a look at what this looks like in the diagram. There's one more thing, okay? The angle of elevation is the same as the angle of depression. What does that mean? Did you guys study parallel lines last year? Okay, do you remember, when you did parallel lines, do you remember when you had this, what was that called, a transverse through the two lines? Okay, and you had to identify what angles were the same, right? And then you had things called complementary angles and supplementary angles, that kind of thing. Do you guys remember that one of the patterns was in the form of a Z? Okay, that the angles in the, I'm going to call this the armpit of the Z. Okay, the angles here, these two angles were exactly the same. If you could form a Z, the angles formed were exactly the same. So what this is, this is a little bit like our line of sight. So what happens is the angle of depression, that's the one on the top here, because I'm looking down. So just think depression is down. So this is from this horizontal line, and I'm looking down. Okay, this angle of depression is equal to the angle of elevation. Okay, I'm going to write this down first, and then I'm going to show you a couple of diagrams to explain how this works. So this angle, this is your angle of elevation, right? I'm at a horizontal. Sorry, I'll do it from this way. I'm at the ground level, and I'm looking up. So that's the angle of elevation. So you just need to know that the two are equal. Okay, so sometimes we will draw our diagram, okay, and when we draw it, we'll just make sure that we have our angle in the right spot. Okay. So the notes that you want in here, okay, angle of elevation is up, rises up from the horizontal. Okay, and let me just move that up a little bit. I know I stand in my way. Okay, and the angle of depression okay, it goes down from the horizontal. Okay, let's draw this edge. Okay, so the first thing I want to do is, okay, you had to go to the bathroom, head up to the bathroom. I want you guys to, we're going to do some board work, okay, and we're going to do some drawing. Today, I'm going to let you to pick your group, okay? So you're going to do groups of 3. I think groups of 3, okay? Okay, so open your notes back up. We're on example number 5. So we have a water bomb, which is a type of airplane. It's flying along at an altitude. So some of the questions might use vocabulary that maybe you're not very familiar with. Okay, so we have to interpret these word problems to then draw out our triangle. Altitude just means how high it's traveling. So that's your vertical distance. Okay, so if I am, okay, this is my, okay, again, I'm not an artist. You guys do amazing things with your art. This is my water bomber, okay, guys? This is the nose, that's the tail, those are the wings. That's the best I can do. All right. So my water bomber is at an altitude. Altitude means height, vertical distance. That one you can draw up and label with 5,000 feet. The plane's radar, so the radar is at the front of the plane, right? And it sends out this signal. The plane's radar shows that it is 8,000 feet away from a target site. Okay, target site is probably a forest fire. Okay, so there's a forest fire raging. Okay, that's the forest fire over here. So the radar on the plane says that the plane is physically 8,000 feet away from the fire. Okay? So it wants to know, so from the target site, it's 8,000 feet away. It wants to know, determine the angle of elevation of the plane measured from the target site. So put yourself at the target site. Okay, so you're near the fire, not in the fire. Okay, you're near the fire, and you look up at the plane, angle of elevation. Okay, so here's the ground. So when you look up at the plane, this is your angle of elevation. Right here. Okay, and any angle that I don't know, I'm going to give it the name theta. Okay, that's that Greek letter. Looks like a 0 with a line through it. Okay, so if you ever don't know what to call it, you can use the same thing. Call it theta. Okay, so then we remember, okay, we've got SOHCAHTOA written at the top of every single page of homework that we do so that we can reference it. So the first thing we're going to do is we're going to label our diagram. Okay, I can tell that this is my right angle triangle here. So opposite my right angle is my hypotenuse. Okay, from my angle of elevation across the triangle, okay, opposite my angle is the opposite side. And in this case, the ground is going to be the adjacent side. Okay, I don't know anything about the ground. I don't have any distances or anything like that, so I'm interested in opposite and hypotenuse. So which trig ratio am I going to use? Okay, so you go up here and you're like, oh, I got this. Okay, sine, okay, is equal to opposite over hypotenuse. Okay, then you're going to substitute your numbers in. So we're going to go sine theta is equal to opposite is 5,000, hypotenuse is 8,000. Okay, so when we want to figure out just the angle, Okay, we're going to put the sign to the other side. We're going to do inverse sine. Okay, 5,000 divided by 8,000. Okay. Go to your calculator, inverse sine, 5,000 by 8,000. Sure all my zeros are there. Close my bracket. Okay, and I just double checked my question. It wants it to the nearest tenth of a degree. So I'm going to have to do some rounding. So I'm going to do here 38.7. Okay. If you wanted to put a nice sentence, okay, the angled elevation of the plane from the target site is 38.7 degrees. Okay, so you can see how important it is to draw a diagram, okay, before you even try to answer the question. So that will help with, okay, figuring out which one is opposite, adjacent, and hypotenuse. So we're going to do lots of triangle drawing practice, okay? Okay. The next question, a set of stairs has a horizontal distance of 5 meters. Okay. So this one is, okay, so literally we have a set of stairs. Okay. Those are, wow, I got really bad stairs. Those are my stairs. Now, if we were to mathematize this, okay, we have a vertical height, we have a horizontal height, and then we have like the actual stairs. So that's kind of what's happening. I'm going to superimpose my triangle, right, on top of my staircase here. Now it says, let's look for keywords. It says the set of stairs has a horizontal distance of 5. Does that mean my stairs are 5? Or just the horizontal part is 5? The horizontal part. So this is the 5.0. Okay, because that's what horizontal part means. It means like the ground under the stairs. Okay, so just kind of like ask yourself the questions and say like, are they saying that the stair, like the stairs are 5? But they've used the keywords here, horizontal distance. Okay, the distance from the top of the stairs to the bottom of the stairs. Top of the stairs to the bottom of the stairs. That's the 6.9. Okay? Okay, so just make sure that when they have it like that, don't go top of the stairs and say that this is the vertical. Because you're not at the bottom of the stairs right here. This is the bottom of the stairs, okay? So I just want to make sure that we can interpret the question so that we can write our numbers in. Okay, it's going to take a little bit of practice. If you're like, dang, I wrote it on the wrong side. Okay, just erase it, right? Correct it. And once you start doing them, you're going to start picking up on the keywords. Horizontal distance, vertical distance, those are the two big ones. So now it says the angle to the nearest degree between the stairs and the floor. Okay, so between the stairs and the floor. That's the angle I'm interested in. If I was at the bottom of the stairs, I would have to look up to the top of the stairs. This is my angle of elevation. Okay. Sometimes that's what they'll say, find out the angle of elevation. Other times they'll just describe it this way, the angle between the stairs and the floor. Okay, so I'm just trying to give you like different words for the same thing. Now you're ready to label your diagram. Okay, cross from my right angle, that's my hypotenuse. Okay, opposite the triangle. Okay, over here, that's my opposite. Touching, okay, touching the angle, this is my adjacent. So if I'm trying to find that angle, what trig ratio am I going to choose? Okay, I heard someone going, yes. Okay, adjacent over hypotenuse. So we're going to do cosine. Okay, so then substitute your numbers in. The adjacent was the 5.0. The hypotenuse was 6.9. We're going to do the inverse cos at 5.0 divided by 6.9. Okay, I'm just going to head over to my calculator. Inverse cos 5.0 divided by 6.9 and my bracket. Okay, and it's set to the nearest degree. Okay, so we get nearest degree, we check the nose and even next door, 5 or above, we're going to round up, so we're going to be up to 44 degrees. Get the little degree sign. Okay, so if this was a numeric response question, don't forget we always start on the left-hand side. Okay, and we would write our number that way. You do not need units in numeric response boxes. So do not put in your little degree sign. Okay, or like say we were talking about a side length and it was in meters, you don't have to put the little m for meters. Okay, just the numbers. Okay, the last one we're going to do before I give you some time to do your homework, okay, is it's one of my favorite. I think I draw this one the best. Okay, you're going to see this an awful lot. Okay, scuba diver, okay, is swimming in the ocean and makes a dive at an angle to the water. So you've got to picture this. Okay, I'm even going to do it in blue. Okay, here's the water. Okay, guys, the water, even though I've drawn it wavy, okay, is my horizontal line. It's kind of like the ground, but obviously the scuba diver is going down, so he's like under the water. So your horizontal line is actually on top this time. So when we draw, okay, my scuba diver, okay, he's going to be here. Okay, all my people are stick people, but I'm going to give him fins, just so that you can tell if he's a scuba diver, and he's got like a mask on. And, okay, he's a scuba diver, isn't he cute? You do much better, okay? You do what you want to do. You don't have to draw a scuba diver, but it just makes it so much more fun. All right. Scuba diver makes a dive at an angle to the water and travels 27 meters. Okay, so if we started here, okay, he's traveled 27 meters. Okay, so this is so at an angle to the water, so this is the angle that he's talking about. At an angle to the water, he's then traveled 27 meters. Okay, so she has traveled a vertical distance of 10 meters. So that's like if I were to go directly on top, okay, and I were to just like go down, this is your vertical distance, up and down is your vertical distance, okay, and that's, so this is your keyword here, vertical distance of 10 meters. Okay, this time, because our ground, and we were looking down from the water, this now, angle, is now called the angle of depression, because we're starting off at the horizontal level and we looked down. Okay? It's just a name for an angle. Okay? It's just a name. So this is the angle of depression. Okay? Just like in this question here, you're interested in from a horizontal and we looked up. This one horizontal and we looked down. Okay, so this is our angle of depression. And it even tells us measured between the water and the path of the diver. So here's the water and here's the path of the diver. Okay, so now we want to do the nearest tenth of a degree. So let's label our triangles. We've got a right angle. You label in the hypotenuse. Okay, which one's the hypotenuse? And then see if you can do the opposite and the adjacent. Okay, so across from my right angle, this is my hypotenuse. Okay, opposite side in my triangle. Okay, this is going to be my opposite. And the one that's touching, okay, so the water here is going to be my adjacent. So I have information with opposite and hypotenuse. Okay. Which trig ratio am I going to use? Sine. Absolutely. Okay. And the reason why I ask you guys to write it out every single time, sine theta equals opposite over hypotenuse, because I want you to be like saying it in your head while you're writing it. I want you to get used to it so that when, right, maybe you're going fast and you just get them mixed up, you should go, oh, wait a minute, that something doesn't seem right there, right? It either doesn't look right, or maybe it doesn't sound right, or maybe it doesn't feel right, okay? Because if we keep doing the repetition, we're going to build in a little bit of that muscle memory, brain muscle memory, and also when we're writing it out. So now go ahead and substitute in your numbers. Opposite is 10 over 27. So we're going to take the inverse sine, 10 over 27. We're going to round it to the nearest tenth. So inverse sine, 10 divided by 27. You guys hopefully are doing this on your calculators so that you're checking your work against mine. Okay, so I'd say 21.7. So what I'm going to do is, I'm going to, okay, give you time to work on page 95, and just remind you that on Thursday, we're going to have a quiz and our homework check. Okay, so the quiz is going to have one question from Unit 1. There's going to be something about factoring. There's going to be a question about radicals or powers. Okay, and there's going to be a couple questions on what we've been learning on trigonometry. Okay, so if you have questions every day, special help, I am here. Okay, ready to help answer your questions.